In the last video we saw how you could go from the formula for a compound to the element percents. Now it's possible to go the other way. You can start with the element percents and get the compound formula. And in fact this is the way it's done experimentally. You do an experiment that measures the element composition of the compound and figures out what the chemical formula for the compound is going to be. These are called empirical formulas. Empirical means experimental. So these will be experimental formulas based on experimental data. In the next video, we're going to distinguish between these empirical formulas and the actual formula for a molecule. But let's not worry about that now. Suppose I've got a compound, and let's suppose it contains, let's see, suppose it's a compound of barium, carbon, and oxygen. And we want to find out what the empirical formula for this is. So really what we want to find is what the subscripts are here. They're going to be mole ratios. This X would be moles of barium per mole of compound. This Y would be moles of carbon per mole of compound, and the Z would be moles of oxygen per mole of compound. So we need to find some mole ratios from these. Now, let's suppose we did an experiment and we decomposed this compound into its component elements, and we found that it's 69.6% barium and 6.09% carbon and 24.3% oxygen. Now you can double check and see whether these numbers make sense. They all ought to add up to 100%. Now you'll see some problems that start out this way that will only give you 2 of the 3%, or they'll give you 1% missing. You can always figure out the last percent. It's going to be 100% minus the other percentages. So you might see that on the homework or on the worksheet. So I'm going to make a table here. This is the element in my first column. This is the element percent, which is given in the problem. Now I'm going to treat that element percent as though it is a mass of element. Now really what that is, when I say 69.6% barium, that means I have 69.6 grams of barium per 100 gram of compound. So I could write in 69.6 grams of barium. And I could do the same with the other element percents. So I've turned the percentages into a gram amount here that I can use in the problem. Now some problems will give you just gram amounts directly, so they don't have to give you the element percents, they can give you gram amounts. But we need to have them written down as gram amounts to go any further. Now remember what we're trying to do. We're trying to get this X, Y, and Z, which are mole ratios. So I think the next thing we should do to form mole ratios is have a column that's moles of element in our table here. And then what we're going to do is convert each of these gram amounts into mole amounts. And we already know how to do that. We need the molar mass, right? Get your periodic table out and look up the molar mass for barium. What is it? You should see it's 137.33, and that's how many grams of barium there is in 1 mole of barium. And you know why I put that grams of barium on the bottom rather than on the top. I can see that if I want this to cancel out and give me moles, that's how I would do it. So I can do the math. If I take 69.6 and divide it by 137.33, I get 0.507 moles of barium. Now let's do that with all of the other gram amounts that we've got. Let's just turn them into moles. So what's going to be different? The molar mass. Now if I look at the molar mass for carbon, it's 12.01. There's 12.01 grams of carbon in 1 mole of carbon. And if I do the math there, it's, wow, the same number as what I got for barium. Okay, now let's try it for oxygen. I'm going to convert it into moles. So I have to have the molar mass of oxygen, which happens to be 16. And that's 1.52 moles of oxygen. Okay, now these are not the subscripts. I mean, X isn't this, and Y isn't that, and Z isn't that. I'm not done yet, because these things are not mole amounts, they are mole ratios. So I can turn these moles into mole ratios, which are the subscripts, by, let's look at this column, and let's pick out the smallest number in the column. Now, it can be either the 0.507 here or the 0.507 here. If I want to make a mole ratio out of this, I'm going to divide everything in the column by the smallest number in the column. Obviously, if you divide 0.507 by itself, you're going to get a 1. If I divide this one by 0.507, the smallest number in the column, I'm going to get a 1. And if I divide this one by 0.507, what do I get? Okay, well this is like 1.5 and this is 0.5, and when I do the math I get 3. Now these are the X, Y, and Z in my my formula. It's BA1, C1, O3, but usually in chemistry we don't write 1s as subscripts. Whenever you get a 1 in a charge or a subscript, you don't write the 1 down. So we shouldn't write it down like that. We should write it like this. This is the compound. Now, occasionally you are going to get a situation where you don't get integers in the last column. Like suppose you had gotten something like this. When you do this compound, you get something like, let's see, a 1 for this, and you get a 1.5 for this in the mole ratio column if you do the rest of the problem. Now what do you do with that? Because you're not getting an integer here. You're getting something like 1.51 or something if there's a little bit of experimental error in your data, but you're not going to be able to round that off to a 2. Now what you have to recognize is that this is really 3/2. So when you get something that isn't an integer in the last column, you have to recognize it as a simple fraction. Now that's going to give you what we would write. Be tempted at first to write this, but that's not right because that needs to be an integer. All of your subscripts need to be an integer. Now I said this was about 3/2. Can I write this? Well, that's a ratio of integers, but that's not quite what I want. I want just plain integers here. Now what you can do, once you recognize what fraction this 1.5 is recognize that there's a 2 in the bottom. And if you multiply the whole thing through by 2, that'll give you the correct formula. This is the one that you want. That will be what it is. So you're going to get this situation sometimes where your mole ratios in the last column are not integers. I mean, what if you see something like 0.20 in the last column? That means 1/5 You know, what if you saw something like 1.66? Okay, well the 0.66 is about 2/3, so that's like 1 2/3, so that's like 5/3. So there's some fractions that you would need to recognize. 0.33 is 1/3, right? And any multiple of this is going to be thirds. You can see that this is 5 times this, so it's 5/3. So you should know that 0.20 is a fifth. You should know that 0.33 is a third. What else? 0.25 is what? A quarter. I don't know. 0.75 is 3/4, right? So you should know how to take numbers that come in the last column that aren't integers and turn them into a fraction so that you can do this with them.